So now we're going into what is mechanical engineering. This is an example of a mechanical engineer who graduated from San Jose State University. So her career path after graduating from SJSU was first going into R&D, research and development. She worked as a mechanical engineer for this company, Zoll, then moved on to be a manufacturing engineer at a company in Pleasanton, and then eventually became a senior technical writer and project coordinator, and has since moved into different design roles past Cepheid, which is a medical device company. So her background is mechanical engineering, but a lot of her experiences has been in biomedical devices, such as these that she shows here. This is one of the examples of a career path for mechanical. And biomedical engineering, for example, is its own career and own major, but mechanical engineers are so broadly skilled that they can enter lots of different fields. Let's take the example of Josie, a new mechanical engineer. So Josie doesn't know what she wants to do after she graduates, and the question is, what's mechanical engineer, even though she studied it, and what do you do with it? The second part is, what can she do for a job? What kind of industries are there, and job titles? And lastly, even after getting a job, what is the context of mechanical engineering? It meets ethics and mechatronics and salary, things like that. So Josie studied mechanical engineering, but what is it? It's a field where you use the principles of motion, energy, and force to drive solutions to problems. So you can think of it as things that are moving, mechanical, having rotation, movement, things that are dynamic. And with that field, it's pretty versatile. You can work at companies that manufacture physical products. So even the manufacturing methods are part of mechanical engineering. And there's also mechanical engineering licensure track. You don't necessarily need it unless it's for specific fields. So civil engineering has a professional engineering license, but for mechanical, it's more or less if you need it for a specific industry. Mechanicals also work on different devices that scale from small to large. It can go from microscale sensors to spacecraft. A quick journey into mechanical engineering. No matter the industry, there is a design process. You follow this iterative design motion. So you start from brainstorm to a define stage, to a design stage, to a testing stage, to a launching stage. So it's always iterative in the sense that there's not a linear pathway to making a perfect design on the first go. So she learned some skills of prototyping, 3D modeling, 3D printing, 2D drawing, and Excel, which is typical of engineering coursework. And she's also heard about some of these industries. So to recap, there's small to large devices. On the left is showing solar-powered automated transportation. So mechanical engineers can work alongside civil engineers to make transportation systems. It includes the actual back-end system of how the transportation happens, like the scheduling and the maintenance of the trains or the roadway, the mechanical systems, so the programming of even the lights or the maintenance of the fans, like emergency fans that go through a tunnel system. And on the right side of this slide, there is a biomedical device. So this robotic arm is used for surgeries. It's part of a startup where they're creating devices that help with cancer detection and surgery. So this device is used by a doctor. They can operate it remotely with a type of controller, like a video game controller or VR, and perform procedures with it. What other projects do mechanical engineers work on? Mechatronics is a system, it's a topic where it combines robotics, electronics, computer science, telecommunications, systems, a lot of different things into one field. You can think of it as objects that have the mechanical part and electronics. For example, these are race cars. More examples, you can work in recycling and robotics. even work on products and manufacturing such as this Xbox. On the left, it shows some typical schools where you can study this field. There's Cal Poly San Luis Obispo, San Francisco State University, San Jose State University, UC Berkeley, UC Davis, etc. Next, Josie graduated, but she needs to apply for a job. What kind of job titles can she apply to? There's robotics, software engineering, mechanical engineering, design engineering, QA, so quality assurance engineering, automotive, even falling into different industries such as biomedical and aerospace. On the right side is Formula SAE. It's one of the race competitions. If you go into university, they race these cars and they get corporate sponsorships and they compete. If you think of mechanical engineering and these different fields as an island, you can imagine that there's different regions of this island, such as research and development. We have the Kingdom of R&D. We have the Republic of Robotics. There's space for robotics and aerospace, computer technology. There's even defense. AI would be a big field where we're combining different disciplines into computer science and AI and automating a lot of tasks that haven't been automated before. There's a mountains of bioengineering. So even biomedical and medical devices would employ mechanical engineers. What are some companies Josie can work at? There's medical device companies such as Johnson & Johnson, Boston Medical, automotive companies like Tesla and Toyota, computer technology companies like Facebook, Meta, defense contractors. There's a lot. This is an example from Boston Dynamics, one of their robots that is doing parkour in this video. Another thing that was mentioned was the transportation system. So this is an example of a mechanical engineering major working on the transportation system. This is taken in a tunnel in Australia. They have these fans that are used for emergencies if they need to evacuate dangerous fumes, or they have these roadway signage that's electronic and it can navigate traffic during emergencies. This internal system is what they use, and has some programming, but not necessarily pure programming. It's more about managing a system, and mechanical engineers can cover that. What's Josie's potential salary average? We can say from a 2020 survey, it ranged a lot. $90,000 was a median annual wage. So looking at a typical job, there's an entry-level mechanical engineer. This one is at a startup, and there's some requirements such as the actual degree, experience with CAD systems, CAD, that includes Onshape. SolidWorks preferred is what this job says here. Familiarity with manufacturing methods such as machining, molding, casting, verbal and written communication, and documentation skills. So a lot of the things from Intro to Engineering will cover that as the foundation, and as you progress through coursework and you practice CAD for real projects, it would be helpful for this job application. So here's a quick case study. This is just for understanding how one would design for some of this biomedical technology, and I'll leave it here that there's a lot of approaches to designing a biomedical device. For example, working with AI and machine learning models, working with the users such as the medical doctors, clinical engineers, understanding different procedures. So you can make documents like this that are technical documents. And there's also questions of the ethics of it. So she's now within the career, and there's topics of, as a mechanical engineer, what kind of systems would you work on? So a mechanical engineer has worked on both biomedical devices and also devices that are used more for defense contracting industries such as drones, so UAVs or unmanned aerial vehicles, weaponry for the military, things like that. This last video is one of the viral videos of surgery on a grape. So the fun part of this video is that it's a remotely controlled surgical robotics device but then all of it's happening inside of a bottle. So yeah, that's the recap. If you want to do mechanical engineering in your projects, there's stuff that relates more to mechanical engineers, such as gears. There's even websites where you can generate gears and understand gear ratios and use them for your projects.